Hi. As I said on my announcement, we're going to try to get back in the classroom next week. It's not going to be in the science and math building. We just got word this morning. It is almost certain that we're not going to be back in the science and math building this semester. So I do have a classroom over here in the engineering technology building that I do not believe is used in our time frame. So I think we can start meeting over there. I'm just going to get final clearance on that. I don't think it's going to be a problem, but anyway, check your announcements. I'll tell you, make it very clear, but try to plan to be on campus next week. Meet with us. I don't know if we're going to get labs pulled off next week. We will try, but please just stay with your announcements. There is enough time after spring break that we can get almost all the labs done. We'll have to double some up, which we were planning to do anyway. And so it's the biology coordinator's got a pretty good schedule planned out. So I think we can get this done. All right. Let's talk about photosynthesis a little more. We started out on that last time. I mentioned that it's broken into two portions. Let's talk about those two portions today. So let's start talking about what we call the light-dependent reactions. This is where the energy is actually stored from light into, and the plants or the autotrophs are going to find ways to create energy storage molecules for them. Let's talk about how they do that. First and foremost, what is light? And we're using light to power photosynthesis. Do you know what light is? And here's where I would wait until I get an answer that kind of makes some scientific sense. So I want you to pause. I want you to think about what is light, have an answer, maybe do a Google search or something on it. What is light? What is that? Okay, so I paused. I hope you paused and found out what light is, and not pause right now and go find out what that is. What is light? Let's talk a little about what is light and how's that energy. Light is a very narrow band. What we call light, what we see, is a very narrow band of electromagnetic radiation. So electromagnetic radiation is it's broadcast, if you will. It's transmitted. It is radiation, yes, and we'll talk about a little bit about what that is. We're not going to get into a lot of physics as to what is radiation. It's basically particles being emitted, very highly energized particles being emitted. Light, what you and I see, right? The light spectrum is a very narrow window of this larger spectrum of different radiation waves that can be broadcast that we use for a number of things. X-rays for, we have film that captures X-rays that are being emitted when we hit a body with X-rays, and then they bounce back, and we use film then to take a picture of that so we can see into bodies without actually having to cut into them and see what's going on. Your TV remote, it will actually send a low frequency light. It's lower than what our eyes can see, but if you have a camera that has night vision, if you shoot a TV remote at that camera, you'll see these flashes coming out of that little bulb on the end of that remote. It's sending a light signal, a very low frequency light signal to the receiver on your TV, VCR, whatever it is. And then the longer waves, these are radio and TV waves. And light is such a very small, what our eyes actually see and detect is a very small snippet of all the possible radiation. So how does that mean energy? How can we use that as energy? So I want you to pause here and think about how does that mean energy? Okay, so what do you think? How does that make energy? And what we find is what is light? Well, light is, again, these particles being emitted, very high energy particles. Those particle, it's being transmitted. That's approaching 5 minutes there. So light's being transmitted as waves. Okay, it's being transmitted as waves. And what that means is that we've got these radiation particles, these highly energetic particles moving back and forth, moving up and down, because they're in 3 dimensions. They can move in all 3 dimensions. We'll pick up there on the next video, okay?